This 2002 problem. Figure shows a part of main scale, M and vernier scale V, of a certain vernier caliper. When their respective zero marks coincide, note that figure is enlarged. Part A1. What is the length of vernier division in millimeters? We have to consider the given diagram. We can identify zero marks are coincide with each other and they have given it. And in this side they have given in it is in centimeters. It means 0, 1, 2 values are in centimeters. Therefore, small divisions in upper scale millimeters, and we can show that we can observe that there is another coincide place in this one. Now we can identify 19 divisions in main scale, 19 times 1 millimeter parts coincide with 20 divisions of vernier scale parts. I will consider length of one vernier scale division is x. Then we can get that distance from this point to this point in vernier scale x times 20. It should be equal to distance from this point to this point, same distance in main scale, 19 into 1 millimeters. Then we can obtain x is 19 over 20, x is length of one main scale division, it is in millimeters. Then 19 over 20 is the answer for A, part 1. Then part 2, tensor otherwise determine the least count of the instrument. When calculating least count, we have to write the equation for the least count. It is compulsory. Least count of vernier scale, main scale division minus vernier scale division. We can write short form or long form, but it is compulsory to write the relationship. Length of one main scale division is 1 millimeter, this part. Length of one vernier scale division is 19 over 20. We can simplify it. We can write 1 is 20 over 20 minus 19 over 20. It is 1 over 20. We can write it in decimal form. 1 divided by 20, 0. 10 divided by 20, 0. 100 divided by 25. It is 0.05 millimeters. Then part 3. According to above figure, what is the least distance in millimeter of vernier scale that has to be moved in order to make the vernier scale mark coincide once again with a main scale mark? I will consider first mark of main scale and vernier scale. I will draw it in a separate diagram. 0, 1. This gap is 1 millimeters. And we know that this gap is length of vernier scale division, 19 over 20. It means if we are dividing it, we can obtain 0.95 millimeters. To coincide this mark with this one, we have to move this distance. It means this one is equal to least count of the instrument, 0.05 millimeters. Therefore, we have to move 0.05 millimeters to coincide first main scale mark with first vernier scale mark. It is the least distance we have to move. If we are moving a distance which is a product of this least count, we can obtain a coincide situation. But they have asked smallest distance, least distance of movement of vernier scale. It should be 0.05 millimeters. When moving 0.05 millimeters, first mark of main scale and first mark of vernier scale will coincide with each other. Then part B, a cylindrical metal piece has a cylindrical hole as shown in the figure. In order to determine accurate values of following measurements, which part of the vernier caliper out of external jaws, internal jaws and depth bar would you use? B part 1. For measurement of D1. D1 means external diameter. To measure external diameter, we have to use external jaws. Then part 2. For the measurement of H1. H1 means external height. When measuring external height, we can use external jaws. Same answer. External jaws. We can't use depth bar to measure external height because of we have to measure this height. We can use external jaws and external jaws to measure the external height of the cylinder, external diameter of a ball or any other external measurements, external diameter of a tube, like that. Then part 3, for the measurement of D2. D2 means internal diameter, internal diameter of hole in this part, this one. When measuring internal diameter, we have to use internal jaws. Then part 4, for the measurement of H2. H2 means this depth of the hole. When measuring depth of the hole, we have to use depth bar. Then part C, write down an expression for the volume of the metal in terms of D1, H1, D2 and H2. We can consider volume of this large cylinder. We know that volume of cylinder is 5r squared h. Now I will substitute 5. When getting radius, external diameter is D1, we have to divide by 2 squared. 5r squared, h is the external height, we have to use h1. They have given, you have to check with given diagram. h1 is the external height. And I will write the equation for this small cylinder. It also 5r squared, 5. Internal diameter is D2, then internal radius D2 divided by 2 squared H2. Now we can obtain volume by subtracting these two values. Volume is 5 is a common factor. D2 over 2 squared H1 minus, large one is this one, 5 D1 over 2 squared H1 minus D2 over 2 squared H2. It is the volume of the hollow cylinder. Then I will get square terms. I will simplify brackets. 5. When simplifying 2 squared, we can obtain 4. It is a common factor. I will get it as a common factor. And then we can write D1 squared H1 minus D2 squared H2. Simplification is not compulsory. If you are writing the answer as this one, it's okay. Then D part 1. When D2 was measured, using the vernier caliper mentioned above. The position of the vernier scale obtained relevant to the main scale is shown below. What is the value of D2? We have to find the value of D2. D2 means internal diameter. We have to get reading in diagram. When getting reading, we can write reading equals main scale reading plus least count into coincided vernier scale part. Main scale reading means main scale value before 0. We can observe vernier 0 is like this, and before value is 1 centimeter means 10 millimeters. Then we can calculate small parts after 1 centimeter: 11, 12, 13, 14, 15, 16. It is 16 millimeter part. Then we can obtain main scale reading 16. Least count 0.05 into coincided part. We have to identify correct coincided part. There are 10 parts from this one to this one. 11, 12, 13. We can get 13 for the coincided part. 0, 50, 100 are only some values. It is not depending to the calculation. Then we can obtain a correct answer. 13 into 5, 65. Then answer is 16.65 millimeters. You have to obtain the answer 16.65. And then part 2, what is the fractional error of D2 measurement? Simplification is not expected. Now we can write fractional error. Fractional error is reading divided by least count divided by reading. Then D part 2, fractional error equals to least count divided by reading. Least count is 0.05. We have to divide by reading 16.65. We can write this one as the answer, or we can remove decimal places. 5/1665.